As the question says, 4 into 10 to the power 23 tritium atoms are contained in a vessel. The half-life of decay of tritium is 12.3 years. Find the activity of the sample and the number of decays in the next 10 hours and the number of decays in next 6.15 years. So we have been given the total number n to be 4 into 10 to the power 23 and t half has been given as 12.3 years. So from here we can find out the activity, which we know that by definition is dn by dt and is also equal to 0.693 by t half. This is actually ln2 into capital N. Why? Because it is lambda n actually, and lambda is ln2 by t, and so that multiplied by n. So this is the formula for that. Putting the values over here, because n is this 4 into 10 to the power 23 and t half is 12.3 years, we get the activity to be 7.146 into 10 to the power 14 disintegrations per second. It's second. Okay. Proceeding to the second part of this question, that is the B part, in which we need to find the number of decays in next 10 hours. Now, as we wrote dn by dt as the activity, we have got the value of dn by dt equals to 7.146 into 10 to the power 14. So number of decays in next 10 hours is equals to, because dn is equals to this times dt, so n is this into t, giving us the required number to be 7.146 into 10 to the power 14 into 10 into 3600, giving us a number of 2.75 into 10 to the power 19. Now proceeding further, that is the number of decays in the next 6.15 years. Now friends, before proceeding to the third part, why did we multiply 3600 is obviously because this rate was in per second and we had the time in years, so we converted this into seconds, right? Similarly, proceeding to the third part, so we can write down the total number equal to n naught e to the power minus lambda t. So we can write it as the 2.82 into 10 to the power 23 now. So this is the number of atoms remained, because this n is what was the sample initially, that was n naught, and now this is actually disintegrating with this constant, so this much of nuclei are left. So this is actually the number of atoms remaining. So what is the number of atoms that disintegrated? That is number of atoms disintegrated is actually total. What was total? It was 2 into 10 to the power 23 minus whatever is left right now, that is 2.82 into 10 to the power 23, giving us the total number of decayed atoms to be 1.18 into 10 to the power 23.